The next question is about curve sketching. So part A wants us to sketch y equals a fifth times 2 to the x. Let's start by sketching y equals 2 to the x. So when x is 0, 2 to the 0 is 1. So our y value will be 1. When x is 1, y is 2. When x is 2, y will be 4. When x is 3, we have 2 to the 3, which is 8, and so on. Now let's look at negative x values. So when x is negative 1, we're going to have a half. When we have x is minus 2, we're going to have a quarter. And we can see that these values are getting smaller and smaller. They're halving. So if we join these points up, we should get a smooth curve, but I probably won't because I'm terrible at curve sketching. Actually, that's not too bad. So you can see here that y equals 2 to the x tends to the negative x-axis. So this means that as the x values get smaller and smaller, our y values decrease and become closer to the x-axis. We call this an asymptote. An important thing to note with this graph is that it goes through 0, 1, which is a key feature of exponential curves. So this is y equals 2 to the x. But the question is not asking for that. It wants y equals a fifth times 2 to the x. So here we can clearly see there's a transformation. Our y values are being divided by 5. So let's plot a few points to get a general gist of the graph. So when x is 0, we're going to have y equals a fifth times 1. That's going to be 0.2. When x is 1, we're going to have y equals 2 fifths. When x is 2, we're going to have y equals 4 fifths. It's 0.8. Now when x is 3, y is going to be equal to 8 fifths. Right about here. And when x is 4, we could have 16 fifths. And this will carry on like so. And when x is negative, so we're going to have, when x is a minus 1, we're going to have a tenth. And it's just going to get smaller and smaller. So let's join this up. So we can see that the curve is clearly below our first one, which was y equals 2 to the x. So here, again, we can see that there is a negative x-axis asymptote. And this is our y equals a fifth times 2 to the x graph. So now we can get rid of our y equals 2 to the x graph. as the question is only asking for y equals a fifth times 2 to the x. Okay, let's have a look at part B, which wants us to solve the equation a fifth times 2 to the x equals 3. And to give our answer to 3 sig fig. So let's try to make 2 to the x the subject. So we can multiply both sides by 5 to make 2 to the x equals 15. And now let's take log of both sides. So we can say log 2 to the x equals log 15. And we can bring this power of x down as a coefficient to make x log 2 equals log 15, as this is one of the laws of log. And now make x the subject. So I have x equals log 15 over log 2. And if we put this into the calculator, we'll get x equals 3.91 to 3 sig fig. Alternatively, you can use another method, which is that we have 2 to the x equals 15. We can say that log 215 equals x, and this would give you the same answer. 3.91 equals x.